everybody, Harold here. This is my second video on imputing missing values in R. I did zoo the last time. Those were kind of simpler methods. Today I want to talk about VIM. VIM is the visual imputation of missing values. It's a great package. The visual part's probably the best part of it. I'll show you. So let's get started. Just explain the methods. VIM. Visual imputation of missing values. It's got three base methods: the donor-based methods, IRMI, which stands for Iterative Robust Model Imputation, and the model-based methods. The donor-based methods are k-nearest neighbor, hotdeck, and matchImpute. IRMI, and then the model-based methods, regressionImp and rangerImpute. These all make much more sense than just doing the median or the mean. They actually take into account the other data and return an imputed value based on some calculations on it. So let's get started. I'm going to go over to R here. Got a lot of little housekeeping. I got a lot of packages here. If you just load all these, install that packages first, and then load them all, tidyverse. VIM, which we're doing, we'll use InspectDF, Skimmer, Janitor, and one thing from Miss Forest today. So most of the video is going to be done on a database called Diabetes. It comes with VIM. There's a lot of good packages out here in the VIM pack. There's a lot of good data sets here in the VIM package to practice your imputation. I'll do one of them with a modified version of Iris also. For now, let's start with the diabetes. Okay, so first of all, I want you to look at the column names with me. We're going to do a little cleaning with Janitor. Some of these are too long and they'll really mess up a lot of the graphs we're going to do. So plots we're going to do. So Janitor package has a function called clean names. We'll just run that. And then that's going to show us these names in lowercase with underscores for spaces. I'm going to now shorten some of them with rename from the dplyr package. So diabetes, pipe that in, rename columns, whatever you want. So let's go ahead and look at that now. Those are a lot cleaner for our plots. Now let's explore the data a little bit. View missingness, types, stats, etc. So glimpse diabetes. And we have, move this up a little. 2, 3, 4, 5, 6 integers, 2 doubles, and a factor. Looks like there's fairly good degree of missing in some of these with these NAs. Let's do a VisDat on it. VisDat, if you haven't seen my VisDat video, shows you types by color. So factor, integer, numeric, red, green, blue, and the grays are missing. So there's quite a good deal of missingness in this data. A lot of it, some of these like insulin. Then another one from the VIM package itself. This is probably one of the greatest things in VIM is you can view portion of missing by column. Our threshold, remember, is about 5%, and we don't want to do much more than 5%. We'd want to find out what's going on. If it was over 50%, we'd drop it. But this looks like some of these down here look like good candidates for imputation. Let's do an MD pattern. Shows you combinations of missingness. There's 336 that everything's there. 119 have one insulin missing. 170 have insulin and skin thickness missing, and so on and so forth. Uh, let's check our thresholds. Percent missing. Looks like BP, BMI, and glucose are great candidates for missing for imputation. Less than 5%, probably at random. We'd want to look more into pregnancies and skin thickness. Insulin's almost on the verge of being thrown out, but probably not because that's pretty important in diabetes analysis. So let's a good look at our data. I'm going to go on to the imputation methods. Donor bases first. They're KNN, hotdeck, and matchImpute. KNN stands for K nearest neighbor, and what it does is picks a row with a missing value, finds a complete row similar to that one, and takes the variable for the complete variable for the missing value and replaces it. So it's finding out what's complete in there for the variable you're trying to impute and replacing it with that. If you pick more than one, it'll do a mean of them for replacement. So KNN defaults to 5. So when I say KNN diabetes, it's going to look at all the NAs, find the 5 closest similar complete rows, and use those for replacement. So KNN diabetes, and you can see it creates all the NAs are gone. They've been replaced, and it creates a shadow data frame that tells you where it's true it was replaced. It's false, it's not. Let's take it down a little bit and only impute the viable candidates. So I said those were glucose, BP, and BMI because they were all in the 5% threshold. So impute imp KNN equals KNN diabetes. The variables we want to do are glucose, BP, and BMI. So then let's take a look at that. And you see it's left the NAs in pregnancy and other columns, but it has done them in BMI, glucose, and BP. And you see the trues in those columns. Let's look at it. Look at AGRA, AGGR, AGRA, diabetes, numbers equals true. That's how you do these cool VIM graphs. So here's the data before we imputed, showing all the missingness. Here it is after we imputed, and you'll see that glucose, BP, and BMI are now all blue. So the great thing now is not only can we see what's changed, it's blue here. If you say agra imp KNN delimiter equals imp, it's gonna plot these shadow frame, data frame columns so we can see what was changed. So now, let me blow this up, drag it over. You can see glucose and BP were red, but we imputed missing values, so now they're this golden yellow. And you can see where it happened in the grid here too. I think that's really powerful, really cool. Let's inspect the NAs. Those columns now all have zeros. Skim it. And those columns all still have zeros down here. And to compare what happened, I'm just going to run the means on the old columns and the new columns just to show you. So the means of the old columns were 72 for BP, 121.6 for glucose, and 32.45 for BMI. So let's run the next three for the IMP. And 72.49 versus 72.40, 121.63 versus 68, 32.37 versus 32.45. So these are really close, good. This looks like a good approximation. This looks like a really good imputation of our values for glucose, BP, and BMI. We could probably take this. Let's do one more thing. Let's look at a histogram. So notice the middle two columns in the spread, the tails, and then when I run the MKNN, it looks pretty much the same. There's kind of a change here, but not too much to worry about. Still a normal distribution, sort of. It looks pretty good. We could probably use that for a valid imputation. Next one is hotdeck. Hotdeck will pick the 5 nearest neighbors, and it doesn't average them. It randomly draws one like from a deck of cards. So you're getting a value, but it's not an average of anything. It does introduce a randomness in which one you use, but it finds those nearest neighbors and just pulls one out of a deck like choosing a card. So let's do that. Diabetes. See the NAs. Let's pick one out here. BMI NA 10. So hot deck, do them all. Let's look at BMI 10, 35.3. So it's done it. It's true. Values look pretty close. Um, let's narrow it down to glucose, BP, and BMI because those are our viable candidates. And let's look at that. So our 35 is 10 on BMI. It's re-imputed, 30.4, but still close. Let's analyze the result. So there it is. All those BP, BMI, and glucose are now filled in. So now you see what's changed in the orange. That's correct. They've all changed. Let's inspect it. All zeros and skim it. Zeros for those columns, so it's looking good. Let's run the means. Old mean, new mean, 72.40, 72.30, 121.68, 121.64, 32.45, 32.46. So this may be even a little better. Another good one. We'll look at the histogram real quick. Okay, watch the tails and the top middle two columns. Wow, that's even better. They didn't even change that much. So this hot deck may be better than KNN. You can decide, keep running them. Pick which one you like. The third donor-based method is matchImpute. And you kind of can choose the predictor variables. matchImpute those for categorical only. So I'm going to switch up the databases. I'm going to make a variant of the iris data set, included with the tidyverse. I'm going to make 10% missing in the species only column. This is categorical, and show you how we can predict missing categories. So the set seed 1, 2, 3 just lets us reproduce the example. Then I'm taking 10% of iris species and making them NAs with this iris.miss. That's from the Miss Forest package. Let me get a summary of that. So now I have 15 NAs in the 10% of 150, 15 NAs in the species column. And matchImpute's going to try to predict what the species was, and I told it just to look at sepal length and petal length. And this is a good example because we'll be able to tell if it was right or wrong just based on where they are in the table. Let me show you. Okay, run that. MatchImpute. Show you imp IRMI. MatchImpute iris miss. The match variables are sepal length, petal length, and then we imputed. You can see we have some. It's all false and everything, but species, and it did convert some. Let's take a look. So we had 15, and we can tell this one by a glance how many got wrong. This versicolor is obviously should be tosa, so that's 1, 2, 3. No, there's a versicolor here, so 4. Got 4, 11 out of 15 correct on the first run just with 2 variables, so that's pretty good. You could go in there in this one and obviously change them, but just be aware it's not going to get them all exactly right, but it's pretty good. So that's matchImpute. Let's look at some of the visual results. Change them all. It did change them all, even though some of them was wrong. There's what it changed, and we have no more NAs in the species column. The next one is the iterative robust model imputation, and that just kind of iterates every variable against the other one, and then gives you the result based on that. So let's show IRMI. Let's just do the 3 columns. Show our repeated data frame. See, it did change what we wanted to change. The values then seem to be out of whack. You can see what changed here because of the decimals, but they look within normal ranges. So that's what it's all changed. That's what changed. And we have no more missing values. Let's run our means. And our means on the imp. Comparison. 3241, 3245, 12163, 12168, 7240. And this one's spelled wrong. 7234, 7240. So those look really good again. Let's look at the histograms. So there's diabetes and IRMI. They look really close. Look at those 2 middle columns. Yeah, that looks pretty good. So the last 2 are model-based imputation. They're a little bit more complicated, but only in the working inner works because you can just run them with a command. But regression actually imputes, does a regression model, imputes. So I'll impute BP based on BMI and glucose. So I subsetted the data set just to take glucose, BP, and BMI. And I said imp regression imp. BP as the dependent variable, BMI and glucose as the independent variables from data set 2, and then run a regression on it. So subset, run the regression, and it's warning you due to missing values in the regressors, it didn't do all of them. So you may have to do this more than once, but going to get a good chunk of them. So in progression, see some changed. You can also see some of them are still there. So we do not BP. So let's look at the agra. Okay, there's what needed to change for BP. Some changed, some didn't. You see over here the red and the blue, like it said in our warning. And it shows a lot of change in BP, but not all of it. So let's check the means for BP. It was 72 before. That's really close. So this is getting even better. Maybe we want to use this one. Check the histogram. I mean, there's a slight difference in those middle two, but not much. That might be a good candidate. And the last one is rangerImpute. The rangerImpute, what it does is, let me get a slide up here. rangerImpute uses what's called a random forest. So one of the basic stats models is a decision tree, and at every branching you make a decision based on predictions, your variables, and the end node, the leaf, will be your decision. Well, this is a really simple explanation. For more, you should go back and read some stats documentation or something about random forests. But so this one will come to the decision, the prediction. So what random forest does is takes a bunch of decision trees, lets them run. I'm talking hundreds, maybe however many you need for the optimal number, and then takes the majority vote from those decision trees and presents it as the prediction. So that's a little bit about random forest. Let me go back to R. So rangerImpute uses the random forest method. Again, we subsetted the diabetes data set to only those 3 columns. And just like on our regression, we're going to run impranger, rangerImpute. BP is the dependent variable, and BMI and glucose is the independent variable. So let's run that. Show impranger with the shadow frame. You're going to see that it got them all, I think. Sometimes impranger will warn you too. But analyze results. Got it. That's what was needed to be changed in red. What changed in orange? Looks like there's still some left. Yeah, there's still 7 in BP. If we just inspected diabetes, I forget what there were. There was 35, so it got 6 out of 7. Let's look at the means on these. That's again really close, so it's pretty good. I think on BP, out of all these, I'd probably go with the regression, even though it missed some. The mean was better. I don't know. You choose. Take all the results, see what's best for you, and then you choose. So that's VIM package. I hope you like this video. I hope you learned something about it. I'm going to be going, this is kind of the intermediate level. I'm going to go advanced with mice on the next one. So I hope you liked this one. If you did, please like and subscribe, and I'll see you next time. Thanks, everybody.